Alright, so this is problem 1b. This time, instead of trying to find the steady state before the switch is closed, we're going to be looking at the steady state after the switch is closed. So, we've still got our voltage source. Alright. You see, he calls it I of L at infinity, which implies that, it's all in steady state. You've got some R equivalent, which I'm going to call R12, because it's the resistance of resistor 1 and resistor 2 combined. We have an inductor here, but at this particular time, the current that passes through it will become constant. The voltage on it will be constant because this is known to be steady state. So it basically effectively becomes 0. Okay, so we've got some voltage across this R12. Okay. Okay, so the voltage across okay. So we're gonna apply Kirchhoff's voltage law. Negative Vs, we're going negative to positive, so it's a negative because it's going contrary to passive reference. Plus R12, excuse me, not R12. Let's call this V12 equals 0. V12 equals Vs. Alright, now, again, we have such a simple circuit that IL is constant everywhere in this, I is constant everywhere in the circuit, so IL is equal to IR is equal to IS, it's all equal. Although, voltage sources are a little weird. Anyways, so we've got V12 is equal to Vs, which equals 12 volts. Alright? So V12 is also equal to the I, which is the I all around this thing is the same, so we can call this IL, times the resistance 12. Let's copy that 12 volts down. Alright, so the resistance R12, these two are actually in parallel, so we're going to have to do the funky way. The inverse of R12 is equal to the inverse of R1 plus the inverse of R2. This is 1 over 4 plus 1 over 1. So we've got 5/4, but that's not our R12, that's the inverse. So our R12 is 4 over 5. So IL equals 12 volts divided by 4 over 5. This is ohms. This becomes 3 times 5 is 15 amps. And let's check. Yep, that's right. So the IL of infinity equals 15A. And that's your final answer. Ugh. Cannot control this brush properly.